Good morning. Hi, my name is Dan Kelly, and I'm joined today by Andy Hassett from Microsoft and Mike Halkovich from Red Hat. And we are hoping to spend the morning talking to you about explaining and understanding the Red Hat and Microsoft strategic partnership, explaining the value proposition of Red Hat OpenShift and deploying containers onto Microsoft Azure, and finally, how containers in cloud can really help you meet today's demanding IT goals. So first of all, to explain and have a little fun in the morning, we came up with the title last night, Cats, Dogs, and Whales, trying to explain the concept of the irony of Microsoft and Red Hat working together, Microsoft's adoption of open source. That's kind of, to me, always seems like cats and dogs living together, and kind of the end of the world. And whales refers to the containers in the Docker whale. So with that, we'll try and keep it light. We're also going to try and keep this to a half hour to leave room for questions at the end. So with that, Andy, why don't you take us away and talk about Microsoft and Red Hat's relationship?
Sure. Thanks, Dan. Thanks everybody for joining us today. We're excited to partner with Red Hat and Anexinet today and in the future to help our customers achieve better data center solutions. And I want to highlight where the partnership is today and where it's going. So today, we have an integrated support capability where Tier 1 support is still with Red Hat, but Tier 1 support for Red Hat has a well-grooved support mechanism all the way back to Microsoft, so that if you call in to Red Hat support, if that Red Hat workload is running on Azure, we have joint sales teams or support teams that sit side by side and troubleshoot the ticket together and cooperatively. So there's a known and well-grooved escalation path. You won't get the pointing fingers. Can you go back to the next last slide? We've also, sorry, we've also become a Red Hat certified cloud partner. So that means that all of the Red Hat subscription data subscription services that you have today are available in Azure, fully supported. And that pertains not only to Red Hat Enterprise Linux, but also to JBoss, OpenShift, and Gluster Storage. So our customers can take advantage of their Red Hat investment in 3 simple steps to upload their Red Hat image into their Azure subscription. And then, in terms of what's coming next, what's in the roadmap now is we will jointly, Red Hat will allow .NET distribution, and right now that's distributed through collections, and coming soon will be the ability to distribute .NET through containers. We have on the roadmap is integration with System Center 2016. The full System Center, so everything from Operations Manager to Virtual Machine Manager, and then also in the roadmap is Red Hat intends to be backward compatible to System Center Virtual Machine Manager. This is very interesting with regard to our strategy with Operations Management Suite, so we can feed Red Hat data into System Center Operations Manager, which then feeds into our log analytics solutions in OMS. So we can get full visibility across multiple OOS workloads running in private clouds as well as public clouds. Still later, we also expect that we will have our own Red Hat update service within Azure that updates the pay-as-you-go on-demand Red Hat images. Right now, that update can be from Red Hat itself directly or from your own private data center. But going forward, we will support an update service running out of Azure. And then lastly, we are working hand in glove with Red Hat around Linux atomic hosts and microservices, serverless compute options. Next slide. And this is, I've got two slides that I want to talk about here called IP Advantage. This is less technical and much more business oriented, these next two slides. But Microsoft a couple months ago came out with this announcement from our legal department. And basically what this does is it speaks to this issue where enterprise customers have deployed open source software in their on-premise and public cloud environments, and kind of malicious patent hounds, I guess is how I would qualify that, will go after and try to find open source software that's in use by these enterprise customers and try to make patent claims. And then this litigation oftentimes results in downtime and customers walking back production applications that they've deployed with open source. What we've done here is we said, if you're going to run open source in Azure, we will completely back that with the power of Microsoft's legal department. And in case you're wondering, our legal department is pretty robust. We are in an active motion with suing our biggest customer, the federal government in the United States, around data privacy. We have good lawyers. So we are ready to stand by open source deployment, not just Red Hat, but other open source distributions and technologies. As long as they're deployed in Azure, we will support that intellectual property so that we protect our customers from malicious litigation. And just to give you a sense of where we stand relative to our competition, if you scroll to the next page, nobody else is doing this. So the two other large cloud providers, no one else offers this protection to their customers. Amazon and Google are nowhere near as close to us on offering this type of legal protection to open source development. So this is not an open source whitewash from Microsoft. We are, actively embracing open source across the board. We are not only supporting Red Hat, but we also are contributing. We are one of the largest contributors to Linux and to many other open source projects. So we are open source friendly. Another last thing to point out, in case people weren't aware, we announced last year the ability to run SQL Server on Linux. So SQL Server could be run on Red Hat operating system. And so with that, I'll turn it over to Red Hat, and at the end, I'll give you a sense of how Microsoft can help invest in Azure pilots with Red Hat.
Okay, great. Thanks, Andy. Hey, everybody, it's Mike Alquich from Red Hat. So I just want to cover OpenShift and OpenShift on Azure. Kind of give you a high-level overview of what OpenShift is from a container technology and kind of where we fit. Again, this will be a high-level presentation given the time that we have. So next slide, please. So what is OpenShift? So what we are, or what OpenShift is a container platform. And again, this is a little bit more than just a container technology, like Docker, for example. So we do support, obviously, Docker containers and Linux containers. But with OpenShift, it's a container platform. And what it allows you to do is install the OpenShift platform on either a virtual environment or a physical environment, or obviously, in Azure, in a virtual world. And it has the capabilities. What you really want, what it's built for, is to allow developers and operations folks to stand up an environment, to be able to develop code, run the code, monitor the environment, how it's working, how the how the containers are working, how the underlying infrastructure works. So, excuse me, excuse me, Tay. So it has a self-service portal, and what that allows the developers to do is to go up and stand up an environment to be able to test some applications or work on their projects. This is a little bit different than the traditional virtualization type of technology where we have to stand up virtual machines and wait for that infrastructure to be built. With self-service portal, with OpenShift, they can stand up their environment on the fly as needed. So just to go around circle here, kind of hit some of the features of the OpenShift environment. It supports multi-language, so we don't really care what language the developers are writing in. So, you know, it could be C, it could be script-based, it could be, you know, Java. We really don't care what the language is written in. The containers will support that. Automation. So the container platform of OpenShift takes care of the automation, excuse me, within the technology itself. So as compared to other container technologies out there, some of that automation has to be dealt with in a manual process. OpenShift takes care of a lot of that, and we'll get into that in an upcoming slide. I'll get into a little bit more on that technology and how that all works. But the automation piece integrated within OpenShift is Kubernetes. So we work very closely with Google on development of that, and so next to Google, we're the second biggest developer or contributor to Kubernetes, which is the automation engine behind the containers. Collaboration. So when we set up a project through the self-service portal, the developers, other developers can jump in on that given project. So we can set up multiple projects when we're developing, you know, code through certain containers. So people can come in and out, you know, at will, other developers on a given project. Then each one could take a small piece of the project to work on. Standards-based, so there are standards based around the technology of containers. Again, I mentioned earlier Linux containers, and we support, obviously, and we also support Docker containers out of the box. Open source, so OpenShift is built from the open source community like all the Red Hat products are. So it's continuous development or development of the OpenShift product and the technologies that underlie the components of OpenShift. So that's constantly being upgraded as opposed to a proprietary solution, which, you know, you're waiting for release cycles that are much, much longer. So we're constantly making changes and improvements in performance and features within OpenShift. And it is enterprise grade. And what that means is OpenShift is our licensed product, again, based on open source. But what we do when we say enterprise grade with all of our products is that we'll take it, we take a look at it, we'll stop, you know, development on it, you know, take a look and say, okay, this is what needs to be checked. We check for bugs. We make sure it's hardened from a security standpoint, which is the most important, and that version is what gets supported, you know, moving on from that day forward. Although within the open source community, development keeps going on and improvements are being made, at certain intervals we come up with a newer release, and that becomes, you know, quote unquote enterprise grade. We harden it, and then that's what gets supported for you in the community. So next slide, please. So this is kind of a little bit of an eye chart, but a high-level view. So we see on the left in the red boxes, let's focus in the middle, you see the master. So that's really the intelligence of the OpenShift platform. And this has everything, all the components needed, from authentication to connections to the data store, schedulers, monitoring of the health of the containers, and as well as the underlying infrastructure such as Azure virtual machines that OpenShift is running on. To the right of that, you'll see we have an example here of 6 nodes. So these would be 6 Red Hat Enterprise Linux servers. And within each of the nodes, you'll see pods which hold containers. I don't want to get too deep into the terminology, but basically that's where your containers run, are inside of these nodes. And OpenShift knows the communication of the nodes, what's living in those nodes, the addresses, the performance of each of those containers within each of the nodes, all the above. So from a developer standpoint, they could just go to the master console, as we said before, create a project, and then just bring up some containers to write their code in, test the code in, share that out with other developers. They can test against that code as well and bring up the containers up and down as needed. Now, what makes OpenShift a little bit different, I said at the beginning, it's a containerized platform. It gives you all that ability, but also has the monitoring ability, right? So we're going to monitor the performance of everything, and it can move containers around. So if one of those nodes becomes overtaxed, for example, and a container is going to crash or crashes, it could be brought back up on a different node, or it could be moved. So it's just like one of the features of monitoring it. Also, it takes care of everything else that we see in the gray area. So if we look around the middle block here, we see the service layer, and then underneath it we see the infrastructure. So when the OpenShift platform is installed and running, it's residing somewhere. So let's just take, for example, it's running in the Azure cloud. There's communication to those devices in the Azure cloud. OpenShift takes care of that. There's no manual processes around networking that have to be taken care of. It also will take care of the registry, and the registry is really a bunch of container images that a developer will use, either to create their own or download and store it. So it hosts that, and OpenShift knows how to access those registries and bring them in for the developers, again, saving them a lot of time and effort and what they need for their tool set. Persistent storage, it takes care of that as well. So persistent storage is needed for containers that need to retain the data. So by nature, when you bring up a container, you can run it, and then when it shuts down or you kill it, any data in there goes away, which is fine for some of the applications. For some of the apps that you need to have data collected and maintained, you need to connect it to some sort of persistent storage. So that has to be introduced into the environment. OpenShift allows you the configuration to that persistent storage, and it's not an extra tool, it's not extra software that has to be done. That's all included with it as far as the configuration to it. And last but not least, we look at top, it's the routing layer. So obviously once your containers are up and running, or you want to test them from an outside address and not an internal, if you're coming across the internet or across the company, you're going to need a routing layer to that to have it talk. Again, OpenShift takes care of that routing layer for you. So it's a lot bigger than just working in a container for writing code. It's more of a platform, if you will, to access it from the outside in, the storage, the underlying infrastructure, the monitoring, all those components. So that's really what OpenShift is as a whole. And then on the left we have the developers, which will obviously access the environment, bring up containers, bring up an environment, test their code, run it. And then once it's up and running, it's in production. The more important part, you see the operators down on the left bottom there. These are the folks that have to monitor and run. So they want to see, what's the performance of the application? Is the application still up? Are there any issues with the infrastructure it's running on? Where are the issues? So because OpenShift controls all that, it also monitors all that, and it feeds it up to another product we didn't mention here. It's called CloudForms. That comes with OpenShift, and that's more of our monitoring tool. It's taking the data from OpenShift and putting it up in the CloudForms. And we could talk about that at a later date, but that's what the operators be looking at. So when we talk about the DevOps world, we're talking about the split here. You got the developer on the top that's actually doing the work and the coding, and you have the operators who are monitoring and managing and making sure that that code and applications are up and running. Okay, next slide. So deploying on Azure. So if we go from the top down, we have our applications that we built. And we go down to the blue bar here, we see OpenShift. So OpenShift is where we're going to develop and actually run the applications within the containers. And then those containers need to reside on something, and those are most usually virtual machines of some sort, we see in the gray area. And those virtual machines have to fit or reside, be hosted on an environment such as Azure, Azure Public Cloud, or it could be an internal bare metal system, or it could actually be both. It could be inside your internal environment, and you can expand out to Azure, for example. Next slide. And finally, the container and stack tools. So this one's a little bit busier, but let's go in a little bit more detail of the previous slide. So if we take a look at the bottom, we have the infrastructure as a service. So we're just saying that the host OS that these containers run and have to reside on some sort of hosted environment, the infrastructure below it. That enterprise-grade container OS we're talking about is Red Hat Enterprise Linux. Your containers are only as secure as the Linux or the host that it's running on. So that's where a lot of security vulnerabilities come about. What we do with OpenShift is that we integrate a lot of the security features that are built into RHEL, Red Hat Enterprise Linux, to really stabilize that and make that enterprise grade ready, as I was saying before. So that's what really one of the differentiators of ours is from a security standpoint. If you take a look into the technology of containers, there are some security vulnerabilities that could be exploited. We shut those down or eliminate those through our integration with the OS. Moving up a level is really the platform as a service, right? So we integrate with other tools around continuous integration, continuous development, CI/CD tools like Jenkins. The developer guys will understand that stuff. It has self-service portal, as I said. Container infrastructure, we support the orchestration, scheduling, storage, the connection to the registry, the security, all that. And again, the container management, monitoring, the policies and just the health of the system itself. And on top, we see the different containers and the different types of applications. So at a high level, that's really what the OpenShift platform is and how the containers play and what the roles are within the OpenShift.
Thanks, Mike. That was a fantastic overview of OpenShift and Red Hat and how it all fits together. Now to kind of wrap it up and explain how containers and cloud and Anexinet, working with our partners, Red Hat and Microsoft, can really change how you go to market and develop and deploy applications. So to start with, obviously, hopefully by this point, based on the hype curve alone, we've heard of containers and cloud and understand a little bit about how containers are enabling composable applications and cloud has evolved to beyond more than just infrastructure in another data center, but really has enabled platform as a service capabilities. So by leveraging these two technologies and concepts, we're really able to start to architect and build applications in a new way. So obviously everyone, I think, also is aware of this move to DevOps, and some people confuse containers with DevOps, but it's really more of a facilitator to allow developers to focus on their problem space, where operations can then take those containers as deployable units and manage those using platforms like OpenShift and tools like Azure and deploying to containers as a service, and really manage that for scale. So what I'd like to walk you through here is some of the impacts that containers have provided on that lifecycle of development. So from develop to deploy, and then really how to scale on Azure. So to start with, containers have really impacted how we develop. First of all, anyone who's spent time on a development machine has installed multiple software in terms of languages. So maybe you're doing Java and .NET and Node now, and all the dependencies that come along with that. By leveraging containers, you've really isolated that to a container, which allows for better dependency management and overall management of that deployable unit. That allows developers to focus on their problem statement. They don't have to worry about setting up an environment for a database or a web front end like Apache or Nginx. They can really just leverage Docker Hub and its registry, which has over 500,000 various containers already pre-built for you to leverage, and can pull those down, assemble the software they need, and get right to building. So for example, if you need MongoDB, there's something out there. If you need Redis as a caching layer, all those can just be pulled down as containers and connected to build a highly complex infrastructure very quickly. Docker, because of its capabilities, gives you 4 to 6 times the ability to deploy instances on your machine than, for example, your standard VM. So having done this for a while, people used to deploy complex scenarios by deploying a pre-configured VM that had the development environment on there because there was a database and a web server and some other caching layer, and something more complex if you're getting into Java and JMS and things along those lines. Now that can just be done in one simple Docker Compose file, pull it down, and let the developer develop with their language of choice and the technologies that they like, and deploy that into a QA environment without having to worry about some of the subtleties of configuration. So from that perspective, it also allows simpler collaboration, because I can then take that Docker file and share it with my other developers so they can pull in those APIs or capabilities that I've been focused on and use them without having to worry about all their configuration and capabilities. It really allows much better debugging and deployment and faster time to market. Sorry, I'm trying to get through these to be cognizant of everyone's time, but the next capability that comes with the development is the ability to deploy. By leveraging containers and platforms like OpenShift, you really can manage that by deploying your containers to the OpenShift registry so they can be deployed as units, either in your local infrastructure or deployed on the cloud in Azure, or both as you go through that. The container registry allows operations to pull those down and deploy them and configure them and really optimize the application for the problem it's trying to solve. So if it's a heavy database intensive application, you can deploy multiple database containers to offset that load across multiple VMs. And if it's a light front end, have only 1 or 2 web containers dealing with that traffic. If it's the reverse, you can flip-flop those containers and leverage that same infrastructure, but optimize it for that scenario that you're solving for. One of the challenges with containers that OpenShift and Azure deploying on that can solve for is persistent storage. As Mike said, most of the Docker containers are ephemeral, so as you pull them down, there's really no storage behind those. So it's very tricky to deploy database solutions and/or anything where you need some kind of persistence across that container. And specifically based on some of the orchestration container capabilities of Kubernetes, making sure that as containers are spun up and spun down, that they're leveraging that same persistent storage so you have the same state across the application. Let's see here. Obviously, the ability to get the flexibility and reliability of Azure on top of that allows for a great experimental environment, because you can really consume a small amount and then have that grow as you expand your deployment and consumption grows to meet the demand of things like IoT and mobile, which are really changing the way applications are consumed. Let's see. Finally, and probably most obviously, is the ability to scale. So obviously, leveraging the cloud and its capability to have a very wide berth of infrastructure to support the scale that you're need in terms of resources, containers allow you really to deploy that horizontally much better than your typical VMs or other capabilities. It also allows you to leverage those platform as a service. So a lot of times we've seen with our clients, people deploy container applications consuming platform as a service like SQL in the back end to really spend and spread that load across various capabilities and manage their price point in the cloud. So with leveraging tools like OpenShift and its load balancing, its ability to migrate those containers across various VMs to optimize utilization on top of the Azure cloud platform, you really get a lot of flexibility and scalability in your solution. And the failover and capabilities along those lines really make it transparent to the end user as you do things like rolling deployments, which allow you to upgrade your APIs and containers without impact. So the traffic is routed appropriately and you can have zero downtime as you move forward. So let's see here. Anexinet, leveraging our partnerships with both Microsoft and Red Hat, is kind of perfectly positioned in the middle, because we have the infrastructure and cloud expertise to help you design that infrastructure and hybrid IT solution on the one hand, but we also have the application development capabilities on the other hand to help you assist with understanding how containers and cloud fit together and leveraging platform as a service like OpenShift to design the optimal solution to support the application needs that you have and the application growth that you're looking to support. So here we are at 9 o'clock, which was kind of our target times. discussing next steps. It's one of the areas we want to talk about. So one of the things that we've been working with Microsoft and Red Hat to do is to put together a 2-hour workshop that we're going to be offering potentially at the MTC, so to do a strategy and planning session to discuss how containers might impact your applications, what you're looking at. Ironically, only 10%, I believe, of organizations, enterprise organizations, are using containers, and a very small percent have those in production. So while people are looking at them, they haven't really done much with them, but yet they are of a great impact and have a high value proposition. And we'd like to move forward that, to get that through and then look at how we might be able to assess your maturity scale to see where you fit into that container and cloud opportunity, and then look to do some pilots as we go forward. I'd like to ask Mike and Andy to jump back in now. We can kind of discuss next steps, and they can also add any comments as they would like to see fit.
Yeah, thanks, Dan. This is Andy from Microsoft. I just want to re-emphasize this kind of order of operations or map in terms of a solution. We're quickly approaching the end of our fiscal year at Microsoft in June, and in July and August, our product management groups will rehydrate funding sources that help us invest in our customers' projects. So we're able to allocate Microsoft's investment dollars to partners like Anexinet, specifically for Azure use cases. And Red Hat, the Azure use cases are top of the list in terms of priority. So if there's an opportunity for you to pilot any Red Hat capabilities in Azure, I think now is the time to engage with Anexinet, scope that work, get that SOW ready for July and August, so that we can immediately go first in line to the funding resources and get, sometimes the entire pilot, the entire migration funded by Microsoft, and if not the entire thing, a significant portion of it. We've done that very successfully with Anexinet, we've done that very successfully with Red Hat, and we're eager to do that. So we want to put that on your radar in terms of a planning exercise, that pilots and migrations of Red Hat technology and Azure, if we get at that now, get us SOW in place, we can go submit that SOW for funding come July, August.
Wow, that's great, Andy. And again, just to reiterate, I think that process would start, and I appreciate you offering. So I said it quickly, the MTC is the Microsoft Technology Center, where we've had great experience by pulling people out of their day-to-day workshop where they can work, so they can focus on the problem statements, diagnose their applications, break them down, and really look to see how this might impact, whether it's cost savings in the cloud, speed to market, so we can talk about CI/CD and DevOps and how containers play there, and really understand and design that SOW for you or with you, and hopefully work with Microsoft to see if there's funding available. So I think that's really appreciate you working with us on that, as we have done in the past. And obviously from that we can work towards going and deploying a full-scale solution, leveraging these new technologies that are ripe in the market. So as far as next steps, which some of which you just heard, we'd like to work with you to schedule your workshop, hopefully with Andy and Microsoft at the MTC. If not, we can do it at the Anexinet offices to discuss that, or your own offices. We're happy to come meet with you on site. Here's some links to get you started as far as Azure and Microsoft and OpenShift, so you can get a deeper understanding. There's some links there that show you how to quickly get started. There's some great demos and ways to kick the tires on both of those. That's another great enabling power of the cloud, is that you can really go experiment, understand the technologies, and then go design solutions that fit those. And with that, I think we are ready for any questions. Patty, do you open the lineup? So it doesn't sound like we have too many questions. I'll assume that means we explained it perfectly. Oh, hold on one second. Let's see here. Oh, no questions. So please, if you have a chance, feel free to contact us. There'll be a follow-up email sent. It'll include a recording of the webinar. Here's some more information, and lots of links where you can go and find detailed information. And we look forward to hearing from you shortly.